Welcome to The Explainer. Today we're piecing together the incredible geological story of the Indian subcontinent. It's a tale of massive contrasts, forged over millions and millions of years. We're going to see exactly how its deep, ancient past created the vibrant, diverse landscapes we see today. So think about this for a second. How can one country have the absolute highest points on Earth and at the same time have people farming below sea level? This one question, right here, gets to the very heart of India's geography. It's a land of unbelievable extremes, and that contrast is the story we're diving into. All right, first things first, let's get our bearings on the map. We're talking about the seventh largest country on the planet. Its sheer scale is kind of hard to wrap your head around, and it sits in this really pivotal spot, right in the heart of South Asia. And here is where it gets wild. Look at that. India has just 2.4% of the world's land area, but it's home to almost 18% of all people on Earth. That incredible population density is a force that shapes literally everything, from its cities and its economy to its relationship with the land itself. You know, it might just be an imaginary line on a map, but the Tropic of Cancer has a very, very real impact. It slices the country almost perfectly in half, and in doing so, it creates two completely different climate zones. Everything south of this line is tropical, everything north is subtropical. That single division pretty much dictates the weather, what you can grow, and even the whole rhythm of daily life. And you can literally trace its journey right across the middle of the country. That line passes through 8 different states, starting way out west in the deserts of Gujarat and Rajasthan, cutting through the heartland, and then finally exiting through the green hills of Tripura and Mizoram in the northeast. Ever wondered how a country this wide, it's huge, manages to operate on a single time zone? Well, the answer is this one line of longitude, 82 degrees 30 minutes east. It runs right near the city of Mirzapur, and that line serves as the standard for the entire country, setting the clock for everyone at exactly 5.5 hours ahead of UTC. So just like that one line sets the time, these 4 points define its vast physical space. You've got Indira Kol way up north in Ladakh, then Gwarmothi in the west, and Kibithu in the east. But check out the south. Kanyakumari is the famous tip of the mainland, the one everyone knows. But India's actual southernmost point is Indira Point, hundreds of kilometers further south, way out in the Great Nicobar Islands. Okay, now for the fun part. Let's rewind the clock, I'm talking millions of years, to see how this subcontinent was even born. We're about to witness one of the most powerful geological events in our planet's entire history. What you're looking at is an absolutely epic journey. See, the land that is now India broke free from that ancient supercontinent Gondwana and just drifted north for millions of years. And then came the collision. It was this slow-motion, monumental crash into the Eurasian plate that crumpled the Earth's crust and basically thrust up the mighty Himalayas. And the most incredible part? That collision isn't over. It's still happening, right now, as we speak. That's why we call the Himalayas young fold mounters. They're not some ancient, weathered-down relics. They are geologically alive and kicking, still being pushed a few millimeters higher every single year. This gives you this fantastic contrast between India's two main landforms. On one hand, you have the Peninsular Plateau. This is ancient, stable stuff, a block of the Earth's original crust. And on the other, you've got the Himalayas, geologically brand new, unstable, and still growing. It's like the ancient foundation of the Earth meeting the new dramatic frontier. So now, let's explore these landforms a little closer. And we're going to start with that great northern mountain wall that really defines the whole subcontinent. See, the Himalayas aren't just one single range. It's better to think of them as 3 parallel walls, each one a bit lower than the one behind it. The Himadri in the back is the highest. That's where you find giants like Everest. The middle range, the Himachal, is where you find all those famous valleys. And then you have the Shivaliks, which are the foothills, sort of the front line of this whole massive mountain system. So what's actually India's highest peak? Well, it's a little complicated. K2 is technically the highest, but it's in a disputed territory. Kanchenjunga, which is the 3rd highest in the world, sits right on the border with Nepal. That means Nanda Devi gets the title for being the highest peak that's located entirely within undisputed Indian territory. All right, let's head south. Here we find the 2 mountain ranges that kind of guard the edges of the Peninsular Plateau. The Ghats. The Western Ghats are like a solid, continuous wall running right down the coast, and they catch the full force of the monsoon rains. The Eastern Ghats, on the other hand, are totally different. They're lower, they're broken up into pieces, and they're sliced through by all the big rivers flowing out to sea. So all this geology, all these mountains and plateaus, it really just sets the stage for the two forces that truly define life in India: water and wind. We're talking about its massive river systems and the powerful seasonal monsoons. These are the absolute lifelines of the subcontinent. India's rivers are just so diverse. Up north, you've got the glacier-fed giants like the Ganga and the Brahmaputra, which is home to the world's largest river island. But down south, the rivers are all rain-fed. And here's a cool thing. Most of them flow east, but there's a fascinating exception with the Narmada and Tapi. They actually flow west because they're following these ancient cracks in the Earth's crust called rift valleys. If you want to understand the sheer power of the monsoon, just look at this contrast. In Mazandaran, literally the wettest place on Earth, they get over 11,000 millimeters of rain a year. A short flight away in Jaisalmer, they get less than 200. That extreme difference in rainfall shapes the entire landscape, the culture, the way of life, everything. So, at its core, the monsoon isn't just a bunch of rain. It's this massive seasonal reversal of winds. In the summer, wet air blows in from the sea to the land, bringing all that rain. In the winter, the whole pattern flips, and dry winds blow from the land back out to sea. This incredible cycle is the engine that drives India's climate. So, with such a diverse and, let's be honest, often challenging landscape, how do people actually live? Well, this next part is all about the incredible, ingenious ways that human life has adapted to India's geography. Let's go down to the coast of Kerala. Here, in the low-lying plains, people have engineered a way to farm rice below the level of the sea. They build these massive earthen walls, called dikes, to hold back the salt water, creating these fields that depend on this really delicate man-made balance. It is a truly stunning example of human adaptation. Okay, now let's jump over to the hills of Manipur. Here you'll find entire communities living on what are called pumdis. These are natural floating islands made of tangled up vegetation. I mean, these things are so big and so stable that they're home to the world's only floating national park. It's an entire ecosystem that is adapted to life on the water. And that brings us all the way back up to the high-altitude, cold desert of Ladakh, which sits in the rain shadow of the Himalayas. This is where the Changpa nomads live. They have this amazing symbiotic relationship with their Pashmina goats, raising these animals that produce one of the world's finest wools by navigating this incredibly harsh, extreme terrain. Which brings us to a final and pretty critical question. We've seen how India is a land of powerful, dynamic forces. Plates are colliding, monsoons are shifting, and people are adapting in incredible ways. But with a changing climate, the ultimate challenge now is one of balance. How can this ancient, diverse land sustain its future and the demands of over 1 billion people? That's really the big question for all of us to think about.